Well, hello, Internet, and welcome to my Precalculus in one video tutorial. Or maybe I should say, hey, look at this, big guy and Stan are here. Hello, thank you for stopping by. I greatly appreciate it. Depending upon, how interested you guys are in this stuff, that's going to determine what I do. And basically, or how many videos I do like this. I was planning on getting into calculus, but, it depends on if people are interested in my format or what it is. What I'm doing, I did some research, and this book right here, James Stewart Calculus, at least in the United States, is the most popular calculus book that is used in universities. As you can see, it's quite large. It's multiple semesters of calculus. And how I'm going to teach is basically, let's see here, where is it? I am going to go through every single problem that is that the James Stewart people say you should be able to solve to be able to enter into and understand calculus. I'm going to solve every single problem live right now, and along the way I'll cover all the little rules you need to know about algebra and trig and a little bit of geometry to be able to solve all these problems. So that is the goal. The problems are going to start off easy and then ramp up in difficulty very quickly. So feel free. Yes, this is going to be on YouTube after. Hello, Wanry and Ethylene 1993. Yes, I will upload this video tomorrow to YouTube. So, and I have to protect my voice, because the last time I did a 3-hour live stream, I lost my voice. So let's just get into it instead of talking. All right, so these are all the problems. I just took them, threw them here, and I'm going to solve them live on the screen. Now, if you get -3 to the power of 4, this, of course, 3 times 3 times 3 times 3, is going to just be equal to 81. Like I said, start off simple. Now, the parentheses are not going to change the results of this answer, so of course, this is also going to be equal to 81. All right, so basic concepts. Now it starts to get slightly more complicated. So what do you do whenever you have a negative exponent? Well, you're going to just go to get rid of it. You're going to put it in the denominator, and then this is going to give you a final result of 1 over 81. Really like the number 81 in the James Stewart Calculus world. Feel free to ask questions as we continue. All right, so we have 5 to the power of 23 over 5 to the power of 21. Well, you can subtract, in these instances, the denominator from the numerator values, and this just leaves you with 5 squared, which is equal to, of course, 25. Now we have another for instance. We have 2/3 to the power of -2. What are you going to do to get rid of the negative value? You're just going to flip those values to get rid of them, and it's still going to be to the power of 2. And then what you can do is just use that power of 2 on the numerator and the denominator to get 9/4. Again, we have a negative value here, but what we really want to do is we first want to be able to cancel out our 4 value to solve this problem. I'm going to write it underneath of it just to make sure that it fits here on the screen. So what we're going to do is we're going to convert 16 into 2 to the power of 4. All right, and that's going to allow us to get rid of that denominator. Please excuse me if sometimes I say denominator when I mean numerator. Doing videos like this, no doubt I'm probably going to make a little silly mistakes. You can point them out in the comments though, because that's good. So if I make a mistake, say, hey, you said numerator and you should have said denominator. That's fine, because then I'll see it and I'll be like, oh yeah, I'm sorry about that. And that's the reason why I'm doing these live, so that if I do by chance say something wrong, you will be able to correct it. So what is this going to convert to? And as you're watching me solve these problems, try to find the next part yourself. Okay, so these 4s are going to cancel, and that just leaves us with 2 to the power of -3. What did I say before? Well, I said you want to get rid of that negative value. You are going to just flip that fraction, and this is going to be 2 to the 3rd, and this is going to be 1 times 1 times 1 still equals 1, so this is going to be 1/8, and that is how we solve that. Okay, so now the next thing we want to do is we want to simplify this formula that we have right here. Cause the negative b negative 81. I thought that indeed was wrong, and indeed it was. Okay, thank you for pointing that out. So yes, that is negative 81. 3 times 3 times 3 times 3 times 3. Yes, if it is outside of the parentheses, does equal negative 81. I apologize. All right, so we'll move on to our next piece here, and what we're going to do is we're going to convert these into values that we'll be able to work with. Thank you, Super64 guy, for pointing out my error there. All right, so what we're going to do is we're going to convert this 200 into 4 times 25 times 2 minus, and then we'll convert the 32 into 4. And see, what we're trying to do is be able to get rid of the square root in this, for instance, or simplify them to the greatest extent that we will be able to. All right, so this is going to be 4 times 4 times 2. Let's get this over here. And then this is going to, since we are trying to get rid of those square roots, this is going to convert down into 2 times 5, which is, we're not going to be able to get rid of the 2 though, so we'll just leave that exactly where it is, minus 2 times 2 and square, or no, this will be, yeah, 2 times 2 and square root of 2. And then this is going to finally go and end up becoming, of course, 2 times 5 is going to be equal to 10 and 2 minus, and this will be 4 square root of 2. And then this gives us a final answer of 6 to the square root of 2. Okay? So slowly ratcheting things up here. All right, let's move on to our next one. Another thing you could do, well, I'm not going to add anything additional to what we have just simply in the book unless I really feel that that is something that would be needed. Okay, so we have 3a to the power of 3, b to the power of 3 times 4a, b squared, and then that is also going to be squared. We're going to go and further simplify these. So this is going to be 3a to the power of 3, b, 3, and times, and let's get rid of that square part. So this is going to be 16a squared and b to the power of 4. And then we could just simply multiply across with those values, and you're going to end up getting 48a, and this will be to the power of 5. We can just add the 3's and the 3 and the 2 to just get that, and then we'll have b to the power of 7. And that is how you solve that. I keep looking over here just to verify that everything is showing up on the screen well. All right, next problem. Okay, so whenever we look at these, whenever we're trying to solve these rather complex sort of formulas, what we're going to need to do is we're going to need to recognize that certain rules are going to allow us to simplify these rather complicated looking formulas. In this first one, we're going to, I've referred to it, but I'm actually going to tell you what it is called. So we want to get rid of this negative value. How are we going to do it? This is called the exponent rule. That is the rule that we have been using. And it just simply says if you have a to the power of some negative exponent, this is going to give you 1 over a to the power of that exponent. Okay, so it's called the exponent rule. So what does that mean? Well, that means if we want to get rid of that negative 2, we're going to have to kind of make things even look worse here for right now. So I'm actually just going to copy this guy. Or you know what would be, yeah, I'll copy it just so that everything's on the same page. So I'm going to say copy and paste right like this. And we'll go in and we'll get rid of that negative value and replace this with 2. And we will put that all under 1. Now that we have this rule set up, we have another rule. And here's another rule. And this rule says if you have a over b to the power of c, that this is going to be equivalent 2a. Again, this is a rule that I showed you previously. And that is all, for the most part, what we'll be doing here, especially with anything, with algebra and also with trigonometry. We're just memorizing certain rules so that we'll be able to utilize them. Another rule that we're going to need here to be able to further simplify this, so I'll write rule again. So rule, and this rule says that if we have a times b to the power of n, this is exactly the same as a to the power of n, b to the power of n. Any other rules? I think just based off of those two rules, I'll now be able to further simplify this. So let's go down here. This is going to be equal to 3 squared and times x to the power of 32 times 2 and times y to 3 squared. Okay, so I'm just going and multiplying those exponents across. That's how we're getting those. Let's make this line straight so it looks a little bit better. And again, this is going to be x squared times 2 times y to the negative 1 over 2 times 2. So I'm trying to get rid of that negative exponent we have here. And then if we multiply all of these across, we're going to get 9x to the power of 3, y to the power of 6, and this next guy gets a little bit sloppy, but we'll fix it up. So we have x to the 4th over y. Another rule that we have, I'm probably going to have to come in here and get rid of some of these rules here to solve these other problems. I'm also going to take all the notes that I have here and I'm going to put them in a worksheet, and I'll post in the description for this video after it's over. I will post a link to that so that you can see everything all in one place. And of course, it's all going to be 100% free. Okay, another rule we have. If we have a over b over c, we're going to be able to convert this to a times c over b. Another rule, and these are basically all the things you need to memorize. If you have x to the power of a, there's not that many of them, but you definitely need to memorize the ones that there are. So this is going to be 1 over power of x b to the a. And then if we apply all of these rules to solve this problem, we're going to end up with 9y to the 7th and over x, and one more. Another thing to remember these were all under 1, so we're going to have to take this value right here. I just got rid of the 1 there temporarily, so let's go and throw the 1 back in. This gives us another rule. Is it even going to fit? Yes, it will. Using all of my screen real estate. So to be able to handle this, if you have 1 over b over c, this is you're going to be able to flip them and get this value right here. And hence, and this is just applied to the 1 and so forth and so on. So that means we're going to end up getting a final result of x to 9y to the power of 7. All right. So those are all the different rules you need, and I can go and copy them now and move them over here so that I can solve all of our other different problems. So let's get this and move this also down here. Okay, so those are all the different rules we needed just to solve that one individual problem. Let's move on. Okay, so in this situation, what I want to do is I want to expand and simplify all of these different problems. It's rather simple, actually. So this is going to become 3x plus 18 plus 8x minus 5. And then I can go and, or no, 20. Sorry about that. 4 times 5 is 20. Last time I checked, 20. And then we'll just simply be able to bring those values together. And if we do, we're going to end up getting 11x minus 2. Okay, there's that problem also solved. Again, in this situation, what we're going to do is use the FOIL method, which means we multiply the first, the outer, the inner values, and then finally the last values. And this is going to get a little bit more complicated though, because we're going to have to use another different rule to simplify that further. So if we have 4x times x, we're going to end up getting 4x squared. Outer, that's going to be minus 5x plus 12x, and then minus 15. And then we'll be able to combine all those. This is going to give us 4x squared and plus 7x minus 15. I have to get a drink every once in a while. All right. And then what we'll need to do is anytime we have a value that falls into this basic layout, so if you have ax squared plus bx plus c, to solve this or simplify it, what we're going to need to do is we're going to need to find two values, a u and a v value. And the rule for them is that u, now this, let me just so that you're 100% certain about this. Let's get this one. Okay, so of course, this is the a value, this is the b value, and this is our c value. So the way the rule says is u times v is going to be equal to a times c. And then you're also going to have it set up so that u plus v is going to be equal to b. And then what you're going to be able to do is group these values. So you're going to have ax squared plus ux and plus vx plus c. And that's it. So you have to figure out what is u and v. Well, I'm actually going to work this out the long way so that you can be able to see how to apply these different rules for solving numerous different problems. So what we're going to do here is we're going to try to find the factors of both 60 and negative 60. So to do that, let's see, do I want to have this be in a different color? Maybe I do. All right, so we're going to have this, we'll just say factors like this. And what are those factors? Well, they're going to be 1, 2, 3, and I'm just thinking of all those values that I'm going to be able to multiply to get either 60 or negative 60. And 5 and 6, and of course you're going to be able to multiply 60 and 30 and 20 and 15 and 12 and 10. There's all your factors. And if I look at all of these, let's see if I can highlight it, I can see that 5 and 12 in this circumstance, so we're going to have 5 and 12 are going to fit in with our rules that we defined right here. And based off of those individual rules, what I'm going to be able to do is then convert this just as I displayed up above. Is this actually visible? Yes, it is. So this is going to be 4x squared minus 5x plus and 12x minus 15. And I might need to get myself some more screen real estate. So let's go and get rid of this problem that we have right here. And then highlight this. And move it up so that I can fit everything on the screen here. That rule's getting in my way. Alright, let's just take that rule, move it also. So we'll grab this. Alright, like that. Alright, so let's move that over. And let's grab this guy right here. And move it up here. Alright, so now I'm going to be able to solve the whole problem here just on this one slide. So now what we can do is we can cancel out or factor out the different common terms. So we're going to be able to get x out of here. That's going to leave us with 4x minus 5 and plus, and the common term here is going to be 3. And this is going to be 4x minus 5. Look at that. It's the same. And then we could factor out the final common term, and that's going to leave us with just simply 4x minus 5 and times x plus 3. And that is how we're going to be able to simplify that rather complicated guy that we have right there. Next slide. Okay, so for this one, it's actually rather simple. This is, again, going to allow us to utilize a rule to simplify this. And that rule says that if you have a plus b and a minus b, as we have right here, well then, in this circumstance, this is going to simplify out to a squared minus b squared. And that, of course, is just simply going to simplify to a minus b. All right. Next problem. I have to get a drink again. So we have 2x plus 3, and that's going to be squared. Well, we're just going to use our FOIL rule once again, and that's going to give us 2 times 2x, so that's going to be 4x squared plus, and then the outer ones, maybe I should write that out. Should I write it out? Why not? So let's just do this a little bit simply. 2x plus 3 and 2x plus 3, just so that it is very easy to understand exactly what's going on. We have a little comment here. Let me just get rid of that altogether. So, boom. All right. So we have that, and we're just going to multiply. So outer, that's going to end up being 6x. Inner is going to be 6x plus 6x. And then the last is going to be 9. And then, of course, this will simplify down to 4x squared plus 12x plus 9. And that's all we can do. That's as simple as it can get. Okay, so now what we have here is what's going to ultimately end up becoming a perfect cube. So anytime you see anything like that and you want to simplify down, you're going to need what's called the perfect cube formula. So that perfect cube formula is a plus b to the power of 3 is going to be equal to a to the power of 3 plus 3a squared b plus 3ab squared plus b squared. Okay? And then to make this actually fit into that formula, we just take the a's and the b's and we throw them into place based off of what the formula says. So this is going to end up just simply being x to the power of 3 plus 6x squared plus 12x plus 8. See, everything is just memorizing formulas. Next problem. 2x squared plus 5x minus 12. Again, we're going to use the same rule that we had before. Why don't I just copy it instead of writing it all out again? So we will just jump over here, get to this guy right here, and go and select this, and then we'll be able to come in and paste it over there so I don't have to write out the rule again. It's actually pretty easy to remember. All right, so get my pen to work, paste. All right, so this is the rule that we're going to use again to try to solve this complicated problem. Well, what are we going to do? Well, we're going to look for the factors of what would end up being negative 24. And let's use this. And let's first off get rid of this little blob we have right here. So here's our factors. And what will they end up being? Well, we're going to have 1. We're going to disregard the negative values. 2, 3, 4, 24, 12, 8, and 6. And based off of that, we see that we'll be able to take the value of 8 and negative 3 to fulfill our rule that we have right here. So let's do that. So that's going to give us 2x squared plus 8x, let's put these in parentheses, plus, and this is basically the same problem as we had previously, it's just slightly different, x minus 12, and we need to factor out the common terms, which are going to be 2x in this situation, which is going to give us x plus 4 plus, and oops, let's just leave that negative. This will be negative 3 is our common term in this circumstance, and this is going to give us x plus 4, and then finally factor out those terms as once again, and that will give us 2x. Oops, it's not on the screen. Let's go and give myself just a little bit more space. So let's grab that right there and move it up so that we can get our final answer in here. Like that. Like that. Okay, so this gives us our final answer of 2x minus 3x plus 4. And there you go. Alright. Next problem, or the last problem that we have here, 4x squared minus 25. And it's going to basically be exactly the same as what we did before. So what I'm going to do, rather than redo that same exact problem once again, what I can do is just simply convert it into 2x minus 5 and 2x plus 5. And there you are. Alright, next problem. I need to get a drink. What software am I using to write? I'm just using GoodNotes. I'm displaying my iPad screen onto my screen and then broadcasting everything out from that. GoodNotes. And is GoodNotes free? I think it's good. I think it's free. That's it. I'm just using GoodNotes. Alright. On to our next problem. Okay, so again, we're going to be doing a lot of factoring here. So we have x to the power of 3 minus 3x squared minus 4x plus 12. We will factor out our common terms, which is going to give us x squared, x minus 3 minus 4x plus 12. And we just factored out our x squared. Now what I want to do is factor out our negative 4. So again, why don't I just factor them both out at exactly the same time? Kind of saves some time, so let's get rid of this. I just did it that way so that it would be a little bit less confusing. So this is 4x minus 3 in this circumstance. And again, we'll just factor out our common terms, which is going to be x minus 3 and x squared minus 4. Another thing we can do here is we can find the difference. We can use what's called the difference of two squares formulas. And what that says is if we have x squared, well, I'll do this in orange so that it stands out a little bit. If we have x squared minus y squared, this is going to be equal to x plus y and x minus y. And what that will allow us to in turn do is greatly expand upon this to turn this into x minus 3, x plus 2, and x minus 2. And there we are. Okay, so we'll move on to the next one. If you're just tuning in, basically what I'm doing is I'm solving every single problem, the pre-calculus problems from this book right here. So basically the James Stewart Calculus book, I'm solving every single problem, and these are all the main concepts that they say you should understand before you're able to properly understand calculus. And I'm just showing you all the different rules you need to know to be able to solve all these different problems. Okay, so in this situation, what I want to do is I want to factor out our common x, and to do that, I'm going to use the sum of cubes formula. So if we have, let's just go and get this common term out here. So if we have x, and this becomes, of course, x to the third plus 27. See, we have our common cubes. And the common cubes formula basically says, can I write it over here? I think I can. X, yeah. X to the third plus y to the third is going to be equal to x plus y. X squared minus xy plus y squared. Okay, another rule. Is that going to fit? Yes, it is. Okay, so now understanding that rule, we'll be able to further simplify this down to x plus 3, and x squared minus 3x plus 9. Okay, and there we are. Next problem. Which one do we want to do here? Oh, this one's going to be rather complex. I probably should have put this on its own slide. What I'm going to do is I'm just going to delete what I just wrote here, and I am going to go and move everything up here. All right, so let's go and select this and move it up. I might have to have a totally different slide to be able to solve this, because this guy is really, really complicated. Okay, so the very first thing that I'm going to want to do here is get rid of the 1 over x with the exponent of 1/2. So let's go and have this be 3x. Let me see. Yeah. Well, I can just go and convert that into a more simplistic form. So just to conserve space, I'm going to make that change to this right now. So let's go and get rid of this, and we'll be able to put the x on the bottom and have it have the 1/2 value. I think that's the best way to sort of show that. Just change that result. And then we're going to have x 1/2, and this will end up being equal to 3x 3 over 2 minus x negative 1/2 9x to the power of 1.5 plus 6, and take this guy, and then of course we're going to have x to the 1/2 on the bottom of it. And now what I want to do is I just want to sum these different exponents. So this will end up being 3x 3 over 2 plus 1/2 minus, and I'm just doing this a long way just so you can see a little bit better what I'm doing, plus 1/2 plus 6, and again put this right here, x to the 1/2, and then this will end up being equal to 3x 4 over 2 minus 9x plus 6 over x to the 1/2. And I want to factor out the 3's on this. Best way to display this, well, that'll just simply be 3x squared in this circumstance. Minus, I don't need that parenthesis in there. It's actually causing more problems than it's worth. Well, this will just become 3x squared minus 3x plus 2. Yeah, let's put the parentheses inside of there. And this is over x to the power 1/2, x to the power of 1/2. And then I want to factor out our x. So this is going to become 3x minus 1, x minus 2. Again, x over 1/2. So I knew this was going to end up becoming a long problem to solve. And then I can use that same rule that we used previously. Say we're using the same rule again. So this is the rule that we're going to be using. So guess what? This is definitely a rule that we use multiple different times. We're using a lot of the rules that I've covered so far multiple times. I'm just not pointing them out every single time because I'd just be listing the rules over and over and over again. So we're going to be using this rule again to find our values of u and v to simplify this formula down even further. And this is going to end up being equal to, can't see that, so let's move it over here and then we'll just delete it because I don't have any room. Don't have enough screen real estate to fit in this long problem. 1/2 x minus 1 and x minus 2. And the reason, of course, is because if we work out these different values, let's get rid of this so it doesn't cause any type of confusion. The u value is going to be equal to -1, and the v value is going to be equal to -2. And this is the simplified version of this rather complex formula that we have right here. All right? But I'm going to have to get rid of this because I'm running out of screen real estate and I want to be able to solve the next problem. Let's see. Can I solve the next problem in this allocated space that we have right here? I think I can. This is a rather simple one. So all I'm going to do here is just factor out our common terms, which in both of these is going to be x and y. So let's get rid of x and y, which just ends up making this equal to x squared minus 4. And then we use another formula, and it's called the difference of two squares. We used it previously to solve another problem. So can I fit that right here? Yes, I can. So if we have x squared minus, y squared, then that is going to be equivalent to x plus y and x minus y. So knowing that, we're going to be able to convert this to xy and x squared minus 2 squared, and then finally xy, x plus 2, and x minus 2. And there we are. All right, next problem. Gonna have to take a drink break every once in a while here. Otherwise, I will blow out my voice. All right, this one's going to be really complicated, and it's sort of going to combine a lot of the same stuff we saw before. Guess what? This right here, this rule is going to be utilized all of the time. If you memorize this one rule here, it is going to be utilized to solve so many different problems. So let's just copy that and let's bring it over here. Very important rule. So paste, there you go. And let's get rid of the little white arrow that came up here. Select this, and then I will position it into a position of prominence because it is an extremely important rule for solving numerous different types of problems. Okay, so we need to figure out what, again, are our values of u and v. And the value is going to end up being, well, okay, so if we have, I wrote that down there, I wrote that down there. Well, in this, for instance, we're going to have, trying to figure out where to write all this different stuff so it doesn't get confusing. Okay, so we'll have u times v. This is going to end up, this is kind of rather simple. So it's going to end up being 1 times 2 is equal to 2. And v plus, or I'll keep consistent. I'll write u plus v. U plus v is going to be equal to 3. So that means that u is going to be equal to 1, of course, and v is going to be equal to 2. So if we factor out x and 2 in this circumstance, that's going to leave us with x squared plus x plus 2x plus 2. And we can go and factor out the x and the 2. So this is going to be x, x plus 1 plus 2x plus 1. And then we can factor out our x plus 1, and that is going to give us just x plus 1 times x plus 2. All right, so there we go. We solved that, the numerator part of this. So now we want to factor out the x squared minus x minus 2. So let's just rewrite it down. Minus x minus 2. We're going to factor same as before. In this circumstance, let's go and write this. U times v is equal to, and u plus v is equal to. So if we have a value of 1 for our u value and a value of negative 2, this is going to work for us. Times negative 2 is equal to negative 2. And u plus v is going to be equal to negative 1. So you can see that all of those are fit in. And then you're basically going to do exactly the same type of factoring. You're just going to have x squared plus x, throw this inside of parentheses, plus negative 2x minus 2. Factor out the x and the 2. X plus 1, and plus, and here well, let's just get rid of that. Let's go negative 2 minus 2, x plus 1, and then we'll further factor. Let's just put x plus 1 and x minus 2, and then we can combine this guy right here with this that we have right here, and that is going to give us an almost complete problem of x plus 1. I could have just copied and pasted those over there, but I decided not to. So x plus 1 and x plus 2 all over x plus 1, like that, x minus 2, and then we can of course simplify that further and get x plus 2, x minus 1, or x minus 2. Okay, another problem done. Okay, let's move on. This is almost like a marathon, just doing one problem after another problem. I don't know how many I've done so far. I've done probably about 15, I guess. And I'm going to solve this problem, and I'm going to go get myself some more tea so I don't lose my voice. Guess what? It is time to learn another rule. And this is called the fraction rule. And I'm going to take all the, after I get this video done, I'm going to take all the different notes that I have here with all the different rules, and I'm going to throw them in the description. Hey, what's up? Thank you for stopping by. Don't know how to say your name, though. Sorry. Okay, the fraction rule is A over B times C over D is equal to A times C over B times D. And what are we going to use yet again? We're going to use this rule. This rule that we have right here. We've been utilizing this rule multiple different times. I think this is what, the 5th or the 6th time we've utilized this to be able to solve a problem. So let's just take it and throw it here. Maybe I should just put this on every single slide. Alright, so what color do we want? Let's just keep the light blue. So we'll then be able to simplify this to x squared minus x minus 1. And we can go and just multiply x plus 3 to it like this. And x squared minus 9, 2x plus 1. And let's go and work on the 2x squared minus x minus 1 value here first. So let's just put 2x squared minus x minus 1. And we will utilize our favorite little formula that we have here. And let's use a different color. Maybe I'll use white for this. So what do we want to do? We want to find the values of u and v that are going to allow us to have u times v is equal to this, and v, whoops, why do I always put the second time? I always write the v first. U plus v is, it doesn't matter, you can do it either way. Okay, so if we have u, and what I'm utilizing here is this rule right here. So u times v is equal to a times c, and u plus v is equal to b. Now, if I do that, I'm going to find that the values that I'm looking for u is going to be equal to -2, and the value for v is going to be equal to 1. So noting that and utilizing what we know about utilizing this formula, this then is going to give us 2x squared minus 2x plus x minus 1. Factor out the x minus 1. 2x, x minus 1 plus x minus 1. And this was then going to become our new numerator is going to be, maybe I should write numerator. So we'll write numerator based off of what we had previously. Our numerator is going to end up being equal to x minus 1, 2x plus 1, and x plus 3, which all comes from this guy right here. All right, then we just want to cancel out the 2x plus 1, and this is going to end up giving us x minus 1, x plus 3 over x squared minus 9. And if we have x squared minus 9, this is going to further simplify down. X squared minus 9 is going to be equal to x squared minus 3 squared. And we can do our difference of two squares again. This is a rule that we used before, so difference two squares. And it says that if we have x squared minus y squared, this is going to be equal to x plus y and x minus y. And then we can just simply go and convert this into x plus 3 and x minus 3. And that means that if we take our numerator and our new denominator like this, and x plus 3, and like that, x plus 3, x minus 3, and of course those are going to cancel out. This cancels out, this cancels out, and we are simply left with, oops, wrong pen, simply left with x minus 1 over x minus 3. And there you go. And that is how you take this ridiculously complicated thing and convert it into this rather simplistic thing. And then we're going to move on, and I'm going to continue solving problems, but I have to take a break because I need to get some tea. So, be back in a minute. Just realized I'm talking and didn't have my microphone on. I apologize. Okay, so to solve this problem, what we're doing here is we're using something called the difference of two squares rule. And we have used this to solve other problems. Yeah, there you are. Oh, thank you for telling me my sound was off. I wouldn't have noticed, and I would have probably finished the whole video. Okay. Okay, so based off of utilizing that rule, we get x plus 2 and x minus 2. See? Just utilizing rules over and over again. Then we're going to use FOIL across the top here. So, what was the best way to do this? Well, basically what we need to do is, since we have x plus 2 here and x plus 2 here, we know that we need to multiply x minus 2 to get a common denominator. So we'll have x squared. I'm just going to write it out again. X squared minus 4 minus and x plus 1 over x plus 2. And we'll multiply it times the one value that's not there, which is x minus 2 and x minus 2. There we go. And if we do that, we'll end up having x squared minus x plus 1, x minus 2. We're going to use FOIL again across the top of this, and this is going to give us our common denominator of x plus 2 and x minus 2, just as we knew we had. If we take FOIL across the top, what I mean is multiply the first, outer, inner, and the last values. We'll end up having x squared minus 2x plus x minus 2 all over our denominator that we worked out before, x plus 2, x minus 2, equal to x squared minus x minus 2, and again x plus 2 and x minus 2, and this is going to end up being equal to x squared minus x squared plus x plus 2. On the screen still, yes it is, x plus 2, x minus 2, which is going to be equal to, we're going to be able to get rid of, yeah, that's going to end up being equal to x plus 2, and then of course, should I write it out? Okay, I'll write it out, why not? This is going to end up being equal to x plus 2 over x plus 2, x minus 1, or x minus 2, I mean. And of course, those cancel out. Let's just, to simplify this, let's just get rid of this. And let's select this guy right here, move it over there, put this here, and put a 1 on top. Okay, so that's simplified. And there you go. And that's how you take this complicated thing and turn it into this rather simplistic thing. Go on to the next one. Thank you very much for subscribing, Zen. I greatly appreciate it. Thank you. I'm trying to do my best out here. Okay, so to solve, yes, you solved it. Yes, that's the you're sitting here solving the problems in the chat as I sit here. Okay, so to solve this next problem, we're going to use another rule. This is the fraction rule. And the fraction rule, and basically what I'm doing is I'm just solving all these problems by utilizing different rules. And I recognize when I need to use them to simplify. So, fraction rule says if you have A over B over C over D, that you, let's make sure that's a D, this is going to be equivalent to A times D and B times C. All right, so if we know that, what we're going to be able to do is, let's go and get this one, and that's how we were able to sort of flip these values that we have here. So we'll have y squared minus x squared x y over xy times x minus y. And this is going to be equal to y squared minus x squared over x minus y. I want to utilize something called the difference of two squares rule, and I'm not going to write out difference of two squares, I'm just going to write out the rule itself. So it says if we have x squared minus y squared, this is equivalent to x plus y and x minus y. And with that knowledge, this is going to then be converted down into, let me see here. Yeah, that's going to convert this down into y plus x and y minus x over x minus y. And I thought I saw something. Okay, let's get rid of that extra blob that we have here. Now the commutative law is another problem. Here we have, and it says if you have x minus y, this is going to be equivalent to minus x plus x. So we'll just continue onwards from this, and that is going to convert this into y plus x and y minus x over negative y plus x, and this is going to allow us to further simplify this down to y plus x over 1. Exactly like that. And then a fraction rule says that if we have, I'm going to make all my rules be in orange. So if you have a over negative 1, that is equivalent to negative a. And utilizing that, this is going to be equal to, well, this should be a negative value. Sorry about that. This is going to be equivalent to negative y minus x, which is equal to negative x plus y. Could I do a series on investing strategies like momentum investing, passive, active, income investing, contrarian, etc.? I covered momentum investing in multiple different ways. I talked about utilizing the Ichimoku pattern. I talked about Bollinger Bands. I talked about, I basically covered that. I even did some crazy stuff with regressions. So I pretty much covered all, a vast majority of that. It's not automatic. Oh, so you're saying take the world of, take the world of investing and just basically turn it into an algorithm. You can do that pretty easily. It's not even really pattern recognition. It's rather simplistic. Like, for example, if you have the Ichimoku system, you're here, I'll talk to you about this. Why not? Well, did I solve this? Yes, I solved this problem. Okay, here, let me just briefly just show you. Okay, so if you have, let me bring up something. I know this doesn't have much to do with what I'm doing, but that's fine. That's why it's a live stream. It can literally turn into anything. Okay, so if you have the Ichimoku system, I said you can talk about anything, and that's perfectly fine. I'm just bringing up like an image here just to look at it. Okay, so let's say you have your Ichimoku system. You have a span A and you have span B. So I'll make span A like this. Okay, so with the Ichimoku, can I go? I really wish I could take something here that was on the screen, throw it on here, and then draw over top of it. But I really can't. So let's just say that you have, we'll have it be white. Okay, so these are your prices. It's simple. Like what you're saying you want to do. It's rather simple. Okay, so let's say this represents your prices that you are investing in. Okay, so this is the price changes on said stock. And you have certain bands which make up the Ichimoku system. And those bands are going to basically, I'm just estimating, this is going to be blue. This is going to, the blue is going to represent what we call span A. And then it's going to sort of fall off and it sort of flat lines. And this isn't perfect, but I'm just giving you a rough idea. Okay? And then you're going to have span B. I'm going to make span B be in orange. So span B is going to start off something like this, and it's going to expand, and then it's going to contract. And span B, maybe it goes down in here, and then it goes like this, and then it expands further. Okay, so what you are trying to do, Okay, so span A is blue. The price data is white, and span B is going to be orange. That's okay. I don't care. I don't care if you're off topic. That's perfectly fine. Okay, so what you're asking me is how hard would it be to be able to go in and predict those stocks that have the most momentum? Well, I already created the tables for you. Or at least I showed you how to make the calculations and create the tables for you. What you want to find is the difference. All you need to do is take whatever the value of, let me get another color here. Let's get like gray. Okay, so if you want a stock that has the most momentum, you want to invest in a security that span A and span B are the furthest apart. Well, that's pretty simple. All you do is take your tables of span A and span B values, and you find that in which if you subtract span and span B, okay, so we'll have span A minus span B is equal to the greatest value. And you just go and do this I showed you in the videos how to generate span A and span B. Well, you just want to search through your stocks, and you want to find the stock at that very moment that you're analyzing with that has this greatest value. And that will tell you, out of the entire world of securities, which stock has highest momentum. Now, I'm not saying that that's necessarily an amazing buying opportunity, and you should just be like, oh, well, this number popped out, so I should buy that stock. No, because things happen. I talk a lot about lawsuits out of the blue, or some invention that nobody was planning on coming. Psychology happens to the stock market. You know, a war breaks out, pandemics, things happen. So I'm saying that, yes, this is a great way to find momentum stocks, but you should also further analyze and make sure that other technical indicators say that, yes, this is a good investment. But this is a wonderful idea, and I've already covered it. The only thing I didn't cover is an algorithm that goes through and finds this value right here, this thing, span A minus span B. So you just have to find it, or you just have to do that one thing, go and add that to the tables that I already showed you how to generate, and then go and search through your whole entire world of stock securities and find that which has the greatest value. Boom, you got exactly what you wanted. Make sense? Well, thank you very much. I greatly appreciate it. All right, so there you go. There's some stock investing information in the middle of a pre-calculus video. That's fine. Feel free to ask me questions on anything. I don't really care. What I'm basically doing here is just solving all these crazy problems. All right. So up next, what I need to do is rationalize the expression and simplify. If you have any other questions, just feel free to ask me, and I'll talk about anything. I don't really care. Okay, so what I want to do is I want to multiply times. Take this right here. This is what we call the conjugate. So square root of 5 plus 2 over square root of 5 plus 2. Oops, plus 2. So it's basically just multiplying times 1. Well, if you do that, you're going to get square root of 10 and square root of 5 plus 2. Just showing how to solve all these pre-calculus problems from this mammoth calculus book that we have here. All right, so our denominator is going to cancel out in this circumstance. This is going to give us square root of 5 times, whoops, no, it'd be still square root of 10, square root of 10 times square root of 5 plus 2 square root of 10. And the radical rule, of course, says that if you multiply the square root of a times the square root of a, of course, you get a back. So this is going to be square root of 5 times square root of 2 times square root of 5 plus 2 square root of 10 is equal to 5 square root of 2 plus 2 square root of 10. Okay, that problem's also solved. If I ever do anything on matrices, that would be brilliant. Yeah, I've done insane amounts of things on matrices. Here, you want a linear algebra video? I'll give you one. I covered matrices in multiple different things. I started doing some machine learning stuff, and I was showing how to do how matrices make everything really, really simple. Do you want a linear algebra video? Whoops, did everything break? Nope. Okay. My whole computer just went crazy. Yeah, I have a whole entire linear algebra tutorial that's absolutely massive. And I will show it to you if you want it. I'm not really sure what to do about these math videos because people say they want to see them, but they're never really a big turnout for them. So I'm kind of like, do people actually want them or not? Here, I'll give you a linear algebra thing, and it covers every single thing you could ever want to know about linear algebra, all in one place. I just have to find it. Just takes me a half a second. That's not it. Linear algebra. There it is. 30 videos. Yes, it's an entire linear algebra course in 30 videos. If I can go and get a link to it. So share, copy, and paste. Boom. There you go. There's a 30-part tutorial on linear algebra. It's literally many, many, many hours of videos, and you know, of course, it's on YouTube. It's free, and there you go. Yeah, feel free. Chances are, you're very welcome. Chances are, if you have a question, like, yeah, hey, did you make a video on something? I probably made the video already. I've made thousands of videos, but YouTube makes it extremely hard to search for content because they're not really interested in videos. Like linear algebra 2 years ago is exactly the same as linear algebra is going to be 30 years from now. So it doesn't change, except the, resolution and things like that. There you go. Okay. So what am I going to do now? Well, in this circumstance, what I need to do is I need to do something called completing the square. So this is another concept, complete the square. And you guys can always feel free to ask me for tutorials. I have had, in the last couple weeks, I've had multiple people ask me for a solidity video. So I'm just going to make one. Probably the next video I make is going to be a solidity video. So there you go. We'll see. Okay, so whenever you're completing the square, what I want to do is I want to convert a formula of the form ax squared plus bx plus c into ax plus d squared plus e. Oops, that's not an e. E equal to 0. All right. So what are we going to do here for this to work out? Well, let's get this here. Well, in this circumstance, d is going to be equal to 1 over 2 times 1 equal to 1/2. And the reason why that is so is because this rule says that d is going to be equal to b over 2a, and e is going to be equal to c minus b squared over 4. Is it 4d? 4? No, it would be yeah, this would be 4a. Oops. All right. So let's continue. D is equal to 1/2, and e is going to be equal to 1 minus 1 squared over, I'm just going to put 4. It's 4 times 1, but I'm just trying to save some time. 1 minus 1 over 4, which is equal to 3/4. And that means that this is going to work out to 1x plus 1 over 2 squared plus 3/4. And if you have this book, you would know that that is right. Thank you very much, Zen. I greatly appreciate the sub. Yeah, I have videos on like every single thing you could ever really imagine. I mean, it's been doing this for quite some time. Okay, so utilizing these same rules that we just utilized in the past for completing the square. Well, we know that A is going to be equal to 2. Why? Because there it is. And B is equal to negative 12 for exactly the same reason. And C is equal to 11. Yeah, I have videos on pretty much anything computer science related. I've probably already made the videos. Solidity is one of the only things I didn't make a video on, so of course that's what people ask for. Okay, so if we know this, then D is equal to, again, we're utilizing the rule that I just showed you above, negative 12 over 2 times 2, which is equal to 4. So this is going to be equal to negative 3, and E is equal to 11 minus negative 12 over 2, which is going to be equal to 144. And 4 times 2 is going to be equal to 8, which is going to be 11 minus 18, which is equal to negative 7. Okay? And then that means that our final problem is going to be 2x minus 3 squared minus 7. There you go. Video on pandas? Come on now, you know I do. Do I have a video on? I have a video on every single thing that applies to data science. Everything. There's not a single thing I don't have a video on in regards to data. Well, I utilize pandas in my financial videos that show you how to utilize data science to make stock predictions and things like that. But in regards to pandas, I have a Learn in One that is 1 hour and 40 minutes, and it literally covers every single thing you could probably more than likely ever want to know about pandas. There it is. Googling pandas does help for. Yeah, there's pandas. There's pandas. I have NumPy. I have. What else do I have? I have no, I don't have PyTorch done yet. I used PyTorch. I never made a video on it though, because I wasn't sure if anybody would care. Let's see. I have a data science playlist that I have like multiple videos on time series analysis, and I think people just don't know these videos exist because nobody ever really watched them. Let me see. Where's my data science thing at? Here, I'll just send you everything all at once, because that would be probably the easiest way. If I could find it. Where is it? So much junk everywhere. Well, I don't know. It's on my YouTube channel. I can't off the top of my head. So I sent you pandas. Here's NumPy. And for people that will like to learn through using real-world analysis, well, I do that also. I have I do that in the data, or it's called Python for Finance, but I show you how to use all these data science principles to invest in the stock market. How in the world? It's all the same stuff. I have videos on scikit-learn. Yes, I have a matplotlib video also. Here's NumPy. Boom. You said you want matplotlib. I got that also. I also have a Seaborn video. I have Plotly videos. Yeah, I mean, I'm sorry it's so hard to find my videos, but it is. I don't know why. YouTube used to base everything based off of the percentage of likes that a video got, and then they got rid of that for some reason, and I don't even understand why things rank the way they rank now. And my like percentage on my videos is normally 99%, but The algorithm doesn't care about that anymore for some reason. All right. So here's Seaborn. Boom. I have Plotly. And like I said, the Python for data science, or Python for finance videos also have all that other stuff. So here's this. Oh, this is Plotly. There we go. I don't know where scikit-learn is. I covered it and I utilized it to do like regression analysis. I'm not sure where I did that at. It was in a video. Time series analysis videos. I think I did some stuff for that in or I did some stuff with scikit-learn and that. Let's see. I'll just put it in here. This is time series analysis. I should just do a weekly stream where I just tell you where my videos are. All my free videos. I was like, oh yeah, here it is. I'd like to have in Ultimate Download an ability to go and update the information in a folder rather than re-download all tickers. Well, you can just run that one download and that will update everything. But I would set it up so that you don't get data that is you know, your old data that you already have. I don't know Yahoo. I don't think Yahoo blocks people for downloading too much data. I haven't seen it, but you don't want to test that out because if you get blocked by Yahoo Finance, that would really stink. All right. Okay, so where am I at? I'm trying to remember what problems I got here. Another question? It takes over 2 hours. It takes 2 hours for you to download that data. Well, you don't really need to have, you know, the utmost newest data. Well, okay, so if you download, let's say you download 5 years worth of stock data. Well, the next time you want to get more, yeah, you get 5 years of stock data. Okay, well then let's say that the next week you want to get all your new data. Well, now you just grab data, all the price data for the last week or the last day. You just need to change your time frame that you're downloading for. And then you'll download everything very, very quickly because, you know, you're downloading very, very small amounts of data. So that you just need to change what I already provided to download, instead of downloading 5 years worth of data, downloading 1 week worth of data. And then you're golden. And you don't need to download, like I see people downloading every 5-minute price changes. You don't need to do that unless you're day trading. Yeah, and then you join your new data with all of your old data. You just repopulate your tables with all that information. That's all you do. Okay. So what are we going to do? If you have any other questions, feel free. This one's actually rather simple to solve this equation. This is just going to be 1.5 x is equal to 9, which means that x is going to be equal to 9 over 1.5, which means x is equal to 6. That was simple. Okay. These problems calculus problems, they sort of start off really complicating and then, you know, go all over the place. All right, so again, we're going to try to solve for x. So we're going to have 2x. Can I fit all this in this little tiny space? X plus 1. I'm going to multiply this times x over x equal to 2x minus 1 over x times, and I'm just getting a common denominator here. That's all that the only reason I'm doing what I'm doing. And this is going to then work out to be 2x squared, which is equal to 2x squared plus 2x minus 1. And that means that 0 is equal to x minus 1, which means that x is equal to 1. I sort of got everything fitting in there. Okay. Any other questions? All right. Yeah. Thank you very much, Zen. I have no idea what I'm doing next week. I might do a solidity video. I'm not sure. That is probably the plan, because a whole bunch of people just started asking me for solidity videos. And I'm like, okay. Again, for this, we're going to use the same rule that we have used countless numbers of times to solve these other different problems. If you're just joining me, I'm solving precalculus, all the precalculus problems from the most popular calculus book in the world. And basically, this is everything you're supposed to know how to do if you want to learn calculus. Everything you need to know before you can approach calculus. So again, this formula right here is going to be utilized. This formula's been used probably to solve at least 6 or 7 problems here. Okay, so what we need to do is find a value where u times v, again, this is the a part 1, -1, -12. So this is a, this is b, this is c. So I just take all that, and that is going to allow me to make calculations, and I want to find values of u times v that are going to equal to a times c, and u plus v is equal to b. Okay? So hopefully that makes sense. If it doesn't, just tell me it doesn't make sense, and I'll explain it further. All right, so what this means is, this is actually rather simple. To solve this, u is going to be equal to -4, and v is going to be equal to 3. Why is that? Well, if you multiply -4 times 3, you get -12. And if you add -4 to 3, you get -1. Okay, there you are. So that means that we can then go and you put everything in this format. I just drew an arrow that you probably can't see. Whoops, you can't see that either. Let's move this up a little bit. There we are. So now that I know what u and v are, and I know what a, b, and c are, I can go and plug these values in here and further simplify this rather complicated problem. So this is going to be x minus 4x plus 3 is equal to 0. And that means that x is going to be equal to 4 and -3. Okay? Because that's the only way you can get those two values. Let's get in. To solve this guy right here, we're going to use something called the quadratic formula. And what it says is, if you have x1, you're going to get 2 values for x and x2. Those are going to be equal to -b plus or minus square root of b squared minus 4ac over 2a. And then when we just got to go and plug those values in. So this is going to be equal to -4 plus or minus square root of 4 squared minus 4 times 2 times 1. Keep that going. This over here. And 2 times 2 is going to be equal to 4. And this is going to end up being equal to, let's go, I'm trying to figure out if I can abbreviate this in any way to keep everything on the screen all at the same time. Yes, so this will be -4. What is the simplest way to do this? -4 plus or minus 2 square root of 2 over 4. I'm just sort of simplifying this a little bit, which is equal to -4 over 4 plus or minus 2 square root of 2 over 4, which is equal to -1 plus or minus square root of 2 square root of 2, which is equal to -1 plus or minus 1/2 square root of 2. All right, next problem. Let's just move on. All right, so to solve, oh, what, I actually copied that multiple times, didn't I? I think I did. All right, so I already solved this. I'm going to solve this problem right here. To solve this, well, I can just simply divide by 3. And if I do, this is going to be x minus 4 is equal to 10 over 3. And then I need to solve for two different values because this is an absolute value. So I need to find x minus 4 equal to -10 over 3. And I also need to solve for x minus 4 equal to positive 10 over 3. And x is equal to negative 10 over 3 plus 4. And x equal to 10 over 3 plus 4. And x is going to be equal to 12 over 3 minus 10 over 3, which is going to be equal to 2 over 3. And x is also going to be equal to 10 over 3 plus 12 over 3, which is equal to 22 over 3. Okay, so that's how to find those two values. Let's continue. Exponent rule again. As you're going to see, if you watch this whole entire video, you'll see that we're basically using the same rules. Exponent rule says that a to the power of b plus c is going to be equal to a, b, a, c. Okay? So what we want to do is we want to factor out 4 minus x to the power of negative 2. And this is going to be a little bit crazy. Another thing to be aware of is the square root of 4 minus x is going to be equal to 4 minus x 1/2, which is equal to 4. Boy, they have really complicated sort of problems in this calculus book. Okay. Before you even get past like page 10, you have to solve all these problems. Minus 1/2. Okay. So now we're going to use these different rules to try to simplify this. So this is going to be 2x 4 minus x negative 1/2 minus 3, 4 minus x to the first, and 4 minus x to the negative 1/2. Something to be aware of is if you have fx over gx equal to 0, then fx is equal to 0. Okay? So what we want to do is we want to figure out how to factor these out. Let's go and do it. All right, so we're going to get 4 minus x to the negative 1/2 minus 3, 4. No, that's not going to be right. Hold on a second here. Sometimes I make mistakes. Okay, so this is going to be 4 minus x to the negative, or to the power of negative 1/2. And then let's get rid of this also. There we are. So this is 2x minus 3, 4 minus x, which is equal to 0. And then this will be 2x minus 3, 4 minus x, over square root of 4 minus x equal to 0. And then just continue simplifying. 2x minus 3, 4 minus x is equal to 0. 2x minus 12, I'm just multiplying through is all I'm doing. 3x is equal to 0. 5x is equal to 12. And hence x is equal to 12 over 5. Wow, that's a lot of stuff. All right, let's move on. Now we're moving into solving inequalities. I don't know. I might have to actually. I thought I would try to do every single one of these problems, but now it's starting to really become daunting. All right. So something to be aware of is if you have A less than U less than or equal to B, well, then you know that A is less than U, and you also know that U is less than or equal to B. So, let's just go for this. -4 less than 5 minus 3x, and we're also going to have 5 minus 3x less than or equal to 17. Well, this will be 5 minus 3x minus 5 greater than -4 minus 5, and -3x greater than -9. Well, we need to multiply by -1, which means we need to flip. So this is going to be 3x less than 9, which means that x is less than 3. And then to solve our other one, what we're going to need to do is subtract 5 from both sides. Maybe we want to put like a dash between these two so you can see that they're two separate problems. 5 minus 3x minus 5 less than or equal to 17 minus 5. -3x less than or equal to 12, and this means that x is greater than or equal to -4. All right, and this also, if we want to put these into what is called interval notation, well, the interval notation for this, well, no, it would be square brackets, -4 and 3. Okay, there we are. Next one. I think I need to get more tea. Basically, every hour of making videos, I have to get tea. Forgot to turn the microphone back on. What am I going to do? Basically, what I was doing or what I was saying was what I was writing anyway. Sorry about that. Okay, so what are we doing here? We're trying to find our x-intercept. Thank you for telling me. So this is going to end up being equal to, well, if we go and want to find our x-intercept, that means that we take a value for y, so this will end up being equal to 4x equal to -16, and that means that our x-intercept is going to end up being equal to -4. Ugh, a little bit complicated. Okay, now it wants us to find the midpoint of our points. This one's actually fairly simple. X is equal to -7 plus 5 over 2, which will be equal to -2 over 2, equal to -1. And y, midpoint between these two lines, is just 4 minus 12 over 2, which is equal to -8 over 2, which is equal to -4. That's how we find our midpoints. Now, if you want to find the length of the line, well, you're just going to get, can I fit this in the space provided? Not sure. Let's move this up here a little bit just to make sure that we can get this up here. All right, so this is going to be x, the second x value minus the first x value squared plus, let me write it out. Okay, the length of the line is going to be x2 minus x1 squared, like this, plus y minus y1 squared, and you're going to get the square root of that. That is the distance. So we just take our values and plug them in. So we're going to have a -7 minus 5 squared plus 4 plus 12 squared, and we're going to take the square root of those values, which is going to end up being equal to Is this on the screen? Yes, it is. 144 plus 256, and then get our square root of those two values together. This is going to end up being square root of 400, which is equal to 20. All right, next problem. Find the equation for perpendicular bisector of AB. Well, the perpendicular bisector is a line that cuts through another line. It cuts through halfway through the other line at a 90-degree angle. Well, we know from previous that the midpoint for our line that we have for those different points is going to be midpoint. And midpoint is this guy right here. So -1, -4. Well, there is our midpoint. It's -1 and -4. Right like that. And a slope is going to be equal to -4 over 3. And what we need to do now is, after I started to recap my whole math on it. I'm in algebra, so funny. That's funny. Algebra is something that is extremely useful, especially if you're interested in data science. Data science, machine learning. I love it when people say, "Oh, I want to learn about machine learning and data science." I'm like, "Okay, well, this is all the math you need to learn." And they go, "I don't like math." And I'm like, "Well, you won't like data science and machine learning because that's all it is math." Okay, so what we're going to need to do is we're going to need to get the negative reciprocal of the slope. So that's going to be 3 over 4. So where do I write this? So we're going to say this is y is going to be equal to 3 over 4, because negative reciprocal of this. Okay, so that's 3/4, and that's the reason why the negative sign goes away. X plus b, and plug these values in. This is going to be -4 is equal to 3 over 4 times -1 plus b, and let's go, and that's going to mean that if we want to find the calculation for b, yes, that's the reason why that's why a lot of people are going back and learning. Well, I wouldn't say a lot, but some people are going back and learning their trigonometry and their algebra. Okay, now to find the value for b, we take 3/4 minus 16 over 4, which is equal to, the final value for b is going to be equal to -13 over 4. Okay, that's what b's value is. And I think I'm going to skip the next part because I already covered it in a previous video, and I want to get into other things. What I'm going to do is I'm going to skip a couple of these problem solving in here, but whenever I post the link to the notes, I'll solve every single problem in there. And if you're just joining me, what I'm doing is I'm taking all the pre-calculus problems from this book. I'm not promoting this book or anything. This is the most commonly used calculus book in the United States universities anyway, and I'm solving every single one of these problems. Why not? Let's just try it. Okay, so for the next one, what I need to do is I skipped the very first question because it's completely simplistic and there's no point in me doing it. So I'm going to skip right to the second one, and this is analyzing functions. And more commonly, we're going to be simplifying a lot of functions. So what I want to do here, the way I'm going to be able to simplify this, is I'm going to use the perfect cube formula, and rather than write it all out, I'm going to actually just search for it. Now, people say all the time, there's so many things you have to memorize in math to be able to solve these problems. But really, you're using the same types of rules over and over and over again. So it's not really that much. If I can find the one I'm looking for, am I going to have to write it out? I know we use the perfect cube. There it is. All right, so this time we're using this formula. See, we're using the same formulas over and over and over again to solve these different problems. So let's just copy that and then go find where we were at. I just wondered what it looked like whenever I flipped through this. Okay, where is the problem I was working on? I skipped that one. Okay, here it is. So I'm just going to paste this in here, and this is a rule. I'm going to put it down here at the bottom so that we'll be able to refer to it. All right, so there's another rule. We're just using them over and over again. Now, this is kind of long looking, so this is going to be converted into a plus 3 times 4 times h. See, it's kind of weird because of the way that this is set up, but this is the way it's solved. You solve it in the same way. We're just using real numbers now instead of using variables, and that's probably why it looks a little bit weird. So 3 times 2, and I'm just plugging all these values in that are defined right here with this equation that we have here. 3 times 2 times x squared plus h to the third minus 8 over h. Over h, so like that. And this is going to simplify down to 8 plus 12h plus 6h squared plus h to the third minus 8 all over h is going to be equal to 12h plus 6h squared plus h to the third over h. And then we can go and get rid of all the values of h that are inside of there using the denominator. So I can just go get rid of this and get rid of this and then go and turn that into h squared. And that problem is also solved. Up next, find the domain of a function. Again, it's covering pretty much everything, and that's why I think these problems are a pretty good overview of what you need to be able to understand it. I mean, if that book says that this is all the knowledge you need to be able to start learning calculus, I think they know what they're talking about. Okay, so I need to find the domain for this function. And the domain is just all valid input values. So by looking at this, you would say, okay, well, what wouldn't be a valid input? Well, what we want to do is we want to find all the possible denominators that would be equal to 0, and that will tell you what won't work. So we're mainly going to focus on the denominator here. We don't care about anything else. And we're going to be using the quadratic formula to find those values equal to 0. Where did I use the quadratic formula so I don't have to write it out again? There it is. So let's go. See, it's not that much. It's the same rules used over and over again to solve these problems. So if you memorize these couple rules, there's a lot of them. There's probably about, I don't know how many. There's a good number. I'm not going to say there aren't a lot of rules to memorize, but there's less than 50. I know that. Okay, so there we go. We have our quadratic formula. So what we want to do is find the values that make our denominator be equal to 0. And if we do that, then we'll know what input values are not valid for our equation here, for the domain of our function. So this is going to end up being -1 plus or minus square root, and I'm just taking these values and plugging them in. 1 squared minus 4 times 1 times -2 over 2 times 1, which is just 2, so I'm just going to write 2 inside of there. Okay, and then I just find all these values. So I'm going to say -1 plus square root of 1 plus 8 over 2. And this is going to end up being equal to -1 plus 3, which is going to be equal to 2, when 2 over 2 is going to be equal to 1. So 1 is going to be one of the values that's not valid, and another one is going to be -1 minus square root, again, of 1 plus 8 over 2. And this is going to end up being equal to -1 minus 3. I don't know why I have trouble writing a 3 over 2, which is -4 over 2, which is equal to -2. So to define the domain, we're going to say that it's going to be all values negative infinity to negative 2. And this represents or. And then we'll say negative 2, 1, or 1 to infinity. So we're basically just cutting out those pieces that are not going to work for us. Next problem. And like I said, I'll put all these, a link to the notebook for all of these. And I'm sort of skipping a little bit some of the problems. Like I said, in the notebook that I put a link to, I'll solve every single one of these problems, but just so my voice doesn't completely die, I'm probably going to skip a couple. Well, for this one, this one's very easy to solve. This one right here. Remember, what we're doing was we're looking for domain, the values that are possible to input into this function. Well, in this circumstance, this is very easy. It's just going to be negative infinity to positive infinity. Why is that? Well, because it isn't possible to get a 0 for the denominator. There's just not possible. So it's literally the input is the world of values. So there you go. All real numbers. All right. Now to solve this problem, what I want to do is I want to subtract 4 from. Well, here's another rule that we need to be aware of, and that rule is if you have a square root of some function x that is greater than or equal to, that it's going to be greater than or equal to 0 under all circumstances. So what we can do here is we can go and subtract 4 from both sides. So we're going to have 4 minus x is greater than or equal to 0, and then 4x minus, oops, no, it's 4 minus, hold on, I'm trying to get ahead of myself, and I'm gonna make mistakes. Okay, so we'll subtract 4 from both sides. So 4 less than or equal to 0 minus 4, which is just going to be negative 4. So this means that x is going to be less than, remember we have to flip whenever we multiply the value by negative 1, we have to reverse the inequality. So that means that x is going to be less than or equal to 4. And then for our other value, we'll have x squared minus 1 is going to be less than or equal to 0. I'm going to add 1 to both sides to solve this problem, and that's going to leave me with x squared greater than or equal to 1. And so that means that x is going to be less than or equal to negative 1, or x is going to be greater than or equal to 1. And I could write out the interval notation. Well, since I'm here, why not? So it's going to go from negative infinity to 1, bracket, or, and then we'll have 1, 2, 4. Like that. All right. What's up next? All right. Now what they get into is recognizing and being able to draw graphs by looking at functions without using your calculator. And what you're seeing here is basically every rule that you need to know to be able to do that, to be able to make graphs without calculators. So there's kind of self-explanatory. If we take a function, we multiply it times negative 1, what's that going to do? It's going to flip it across the x-axis. What happens when we add 1? Well, it's going to move whatever graph we have up 1. If we subtract 1, it's going to move it down 1. And you can see everything there. I'm not going to explain every single one of them because, you know, you guys can read. And like I said, I'll give you the notebook for free, and I'll put a link for it later on. So what did I just say? Negative fx, it's going to flip the graph across the x-axis. I don't think I need to write that down. In the circumstance in which we have 2 times a function minus 1, I'm referring to this problem right here. Well, using this table up here, what's that going to do to our graph? Well, it's going to stretch it away from the x-axis by a factor of 2. That's what the 2 does for us. And then it is going to move the graph down 1 point. That's what the negative 1 does. Okay? Now let's move on to this one. What's it going to do? Well, the 3 is going to move our graph to the right by 3, and the 2 is going to move the graph up by 2. There we are. I think that's pretty self-explanatory. Then what I did was, this wasn't in the book, but I thought it was very important to know the basic polynomial functions so that you can basically look at a function that fits these formats and know what the graph is supposed to look like. And that is an example. There's some. So without a calculator now, what I'm going to do is come in here and try to sketch in exactly what these graphs look like. Well, what I'm going to do here first is sometimes you can just use a basic format, and sometimes you solve a couple problems and you get an idea. Remember, the concept or the idea of this is to get a sketch of what it looks like, a rough estimate. It's not to be absolutely perfect. So if we have -2 for x, this is going to be -8. 0 is going to be 0. 2 is going to be equal to 8. So what that means is I'm going to have to use a dark color in this circumstance. So let's just go and grab this. So we're going to have a point in the center. We're going for +2. They're going to have an 8. So I can put a point up here. -2, I'm going to have a -8. And then what I can do is I know that the graph is roughly going to look very, very much like what you see right there. Okay, next one. Well, for this one, it's quite simple. I just know that I'm going to move the graph left by 1. So we will be able to, without thinking much at all, we're going to have a point right here. We're going to have a point right here. And we're going to have another point down to -8, which is going to be right here. And we will be able to very quickly come in and graph that also. All right, so I didn't even have to write out any points or do anything. It was just very, very simplistic. Next problem. Well, what's this telling me? It's telling me the same thing. It's saying that I'm going to move my graph that I have right 2 and up 3. No problem. So I'm using that same, taking this function to using the exponent of cubing it. Okay, so where's this going to go? It's going to go 2, 3. So 2 and 3. There's that point. It's going to go to 0 and -5, like this. And then it's going to be up here somewhere. So it's going to be like up in this vicinity up here somewhere. So I can just look at that, know those rules that I showed you first, and then be able to graph things. I don't even have to think. Okay, so for the next problem, we see that we're going to have a reflected square function that's going to be moved up 4. How do I know that? Well, you can just see there. This is a square function, okay? This guy right here, and moved up 4. Well, you can see in this circumstance how we're able to subtract. So we'll either move up or move down depending upon what the formula does. All right, so let's come in and let's basically find the basics of this. Well, we know that we're going to have a point at 0 and 4 right here. And we also know that we're going to have a point, which is right here and right here, based off of what we know about the fundamental rules of using these types of functions. Boom and boom. There you go. You just drew another one. It's kind of interesting how you can just do this. The square root function, again, based off of what I covered before. We're not going to have to think. We're just going to be able to come in here. Whoops, wrong color. Have a point right there. We're also going to have a point at 4 and 2. And then we're also going to have a point that is going to be, yeah, roughly in this vicinity. Boom. And then we just draw it in. And then you can refer to the previous charts to see how that works. Now, if we go and get the square root function and multiply it times 2, it's just going to move away from the x by 2. That's all it's going to do. So we'll still have our point right here. But for 4, like this, it's going to be in this vicinity. And then for 9, it's going to be in the 6th vicinity like this. And then we can go like this and draw it in there like that. For these last ones, again, we're basically still doing the same thing. And just because my voice is going to die, I'm not going to write out this problem also. Let's just move on. Well, this last one, it's different. So I'm gonna cover this one. Okay, so in this situation, it's having a function in which we are actually going to use different formulas depending upon what the values of x are. And what I know is this guy right here is doing what? It's reflected squaring up 1 point. That's basically what that means. When I look at it, that's what I think. I need to draw a graph that represents that. And then for this one, I am going to stretch away from the x-axis by 2. And then just with that little bit of knowledge, I'm going to be able to come in here and draw all the different points. So I'm going to be able to have a point right here on 0. I'm going to be 2 and 5. Again, just rough estimate. And then we're also going to be 3 and 7, like that. This is basically a straight line. And then we're going to have this curve down from this point. So it's going to be 2, -2, like that. And 3, -8. So if we go and draw this in, it's basically going to look like this. And then it's going to curve down. All right. Hey, we got it. All right. Next one. Okay, so now what we're going to be doing is we're going to be using the concept of having functions composed into other functions. And that's what this is. This is actually saying right here that f is composed with g of x. And so let's go and take these two functions and combine them together to solve, basically solve the problem. Okay, so this is going to turn into 2x minus 3 squared plus 2x minus 3 minus 1. And then we just multiply through, so this ends up being equal to 4x squared minus 6x minus 6x plus 9 plus 4x minus 6 minus 1. And equal to, cancel out, 4x squared minus 12x plus 4x plus 9 minus 7. And then we get a final problem, 4x squared minus 8x plus 2. Okay, then we have g composed of f. And that's going to give us 2x squared plus 2x minus 1 minus 3. And we just continue, 2x squared plus 4x plus 2 minus 3, which gives us a final answer of 2x squared plus 4x minus 5. All right. And then you could sort of do compose. This actually looks a lot more complicated than it is, so I'm just going to solve it. Can you see it on the screen? Yes, you can. Okay, so 2x minus 3 minus 3 minus 3. So it's sort of stacking upon each other. And then this simplifies down to 4x minus 6 minus 3 minus 3. And then finally it becomes 8x minus 12 minus 6 minus 3. And I'm just going to go and add all those together and get -21. Boom. What's up next? Boy, blowing through these problems. What else do we have? Once again, this first problem is basically exactly what I already solved. Like I said, I'm going to put the full solutions in my notebook, but I'm not going to do those right now. I'll do these very briefly because they're extremely easy. So this is now starting to get into the world of trigonometry. And if you want to convert degrees into radians, you are going to just go degrees times pi over 180 is going to be equal to radians. So that's how we'll do that. And I don't think I covered the greatest common factor, did I? Well, I'll cover that now. And if you have radians and you want to convert those into degrees, you just multiply that times 180. over pi, and that gives you degrees. So there that is. All right. So now knowing that, well, let's go. We'll have 300 times pi over 180 is equal to 300 pi over 180. Now let's say that this is not a very simplistic number. We're not dealing with 300 and 180. Let's say it's really complicated and we want to simplify it. To do that, you have to do something called find the greatest common factor. So how do you do that? I don't think I've covered that yet. And I don't know what the book, I don't know. So what I'm going to do is I'm just going to show you how to find the greatest common factor. Well, I'm going to specifically show you how to find it using what we call prime factorization. Let's do it in a different color. Let's go and take this and move it down here. And this is how it works. So we're going to take 300 and we're going to find all the prime values that you would multiply times each other to get 300. Well, if I multiply 2 times 150, I would get 300. So now I have to find 150. Well, if I multiply 2 times 75, I get 150. Should I write these in? I don't know. I don't want to. Sometimes I have a hard time figuring out what is confusing. So I'm going to put, so this is going to be multiplied times 150 to get 300, all right? Now our goal is to get 75. So we're going to have 75 times 5. And then we are going to have 15 times 5. So 15 times 5 times 3. Okay? So those values, when multiplied, times each other are, no, I messed up. I missed a 5. Sorry about that. So this is going to be 15 times 15 times 3. Okay? And then, so 150 times 2 is going to give us 300. Then we want to make 150. Well, we multiply 75 times 2 to give us 150. To get 15, and then 5 times 3 is going to equal to 15. All right, hopefully that makes sense. If it doesn't, tell me it doesn't make sense. Hey, what's up? My bodies. I think that's how you say your name. Thanks for stopping by. All right. So now I need to find all the prime values I need to multiply together to calculate 180. So I'm going to take 180 is equal to 2 times 3. Again, that is going to be 90. And then I need to multiply again. This is going to be 5 times 3 times 2. I think you get what I'm doing here. Okay, so after you find all those prime values that you multiply together to get those values, what you do is you find those that are in common. So there's a 2 here, there's a 2 here, there's a 2 there, there's a 2 there, there's a 3 here, there's a 3 here, there's a 5 here, there's a 5 here, and all I'm left with is a 3 and 2 5s. So altogether, what we have is the greatest common factor is going to be equal to, take all the values that are in common. So that is 5 times 3 times 2 times 2 is going to be equal to 60. And now that we know that that is going to be equal to 60, we can divide 300 by 60 and 180 by 60. And that means that we will end up getting 5 pi over 3. Okay? And again, I'm not going to do this again for degrees. I think you get the point. And if I want to convert negative 18 into radians, again, we're going to just use the formula that I already covered previously. Negative 18 times pi over 180 is equal to negative 18 pi over 180, which is equal to negative pi over 10. Okay? Got it. My bodies. Oh, my bod easy. Okay. My bod easy. That's funny. Um, I use normally I just use my name for like almost everything, and whenever I don't use my name, I use I'm Bananas because of the weirdness of my last name. Okay, so find the length of an arc. How close to we are being done? Wow. Oh, we're almost done. All right. I didn't know that I could if it was humanly possible for me to solve all these problems in one video, but it looks like it might be possible. As long as I can keep my voice from dying. Okay. So I need to find the length of an arc of a circle with a radius of 12 centimeters if the arc subtends a central angle of 30. Okay. So, well, that means that our length, so it wants to find the length is going to be equal to 30 and multiplied times pi over 180 times 12, which is going to end up being equal to 360 pi over 180, which is going to be, the length is going to be 2 pi centimeters. All right. If I want to find the exact value, well, this first one is really simple because there's a rule, and that rule says if the tangent of pi over 3 is going to be equal to the square root of 3. So that's the answer to that. Now things get a little bit more complicated whenever we're dealing with sines and cosines, and trigonometry actually gets kind of really complicated. I think I'm going to have to take another break because I think I need some more to drink. So I'll be back in, it'll take me like 2 minutes. Be back in a sec. All right, I'm back. Thank you for hanging out. Okay, this next one's going to be a little bit more complicated to solve. All right. Drinking the greenest tea on earth. I don't know how many teas I've actually been drinking. I think it's about my 5th tea. Okay, so, okay, this can be simplified down so that we can actually work with it into pi plus pi over 6. And here's a rule that we need to know. If we have sine x plus y, this is going to be equal to the sine of x times the cosine of y plus, I guess I have to go to the next line, cosine of x times the sine of y. Another rule. So let's just fit this in here. This is going to be equal to sine of pi times the cosine of pi over 6. So we're just plugging the values in that we know. Cosine of pi and the sine of pi over 6. And the cosine of pi is equal to -1. The sine of pi is equal to 0. That just leaves our other different rules that we need to memorize. On the very first slide of this entire presentation, I have how the radians convert into degrees and so forth and so on. So this is basically sine of pi is going to be equal to 0 times the cosine of pi over 6 is going to be equal to, and there's a trick that I talked about earlier about how to memorize just a couple different conversions between radians and degrees, and then you'll be able to, just out of your head, just make calculations. Plus, and this is -1 times 1/2, and this is going to end up being equal to, well, it was 0. It just cancels out the square root of 3 over 2, so this just gives us a value of -1. All right. And the secant, this one's actually really complicated. I'll work through it just because why not? I think my voice is probably going to last through the rest of the tutorial and solve all these problems. So I am going to do this one. This one's a little bit complicated. Okay, so we know that this is another rule. I'll write the rules over here. Cosine of x is going to be equal to the sine of pi over 2 minus x. So what we can do here is we're going to be able to say that this is going to be equal to the cosine of 5 pi over 3 and under 1. And then using our rule that we just talked about here, we're going to be able to say sine of pi over 2 minus 5 pi over 3. Like that. Straight line. There we are. And this is going to be equal to the, well, here's another rule. The sine of a negative x is going to be equal to negative sine of that x value. It's not really that complicated of a rule. So this is going to be the sine of negative 7 pi over 6 over 1. Whoops. Over 1 like this. And so this is going to end up being equal to negative sine of 7 pi over 6 over 1, or under 1. And if we go and make this calculation, this is going to be equal to negative 1 over 2 over 1, which is going to end up being equal to 2. All right, boom, next problem. Well, how many more of these do we got? Not that many, I don't think. Let's move on. Okay, so if we have sine of x is equal to 1/3 and the secant of y is equal to 5 over 4, where x and y lie between 0 and pi over 2, what I need to do is evaluate sine of x plus y. Well, we're going to use the Pythagorean theorem. So the Pythagorean theorem, this is another rule that we need to know. It's pretty simple. Pythagorean theorem. Theorem. I don't think I've ever had to do this many math problems all at one time in my life. So x squared plus b squared is equal to c squared. Just as a rundown to SOHCAHTOA, sine is equal to the opposite over the hypotenuse, cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. Do I need to write those? I'm not going to write all those down. I think you guys already know that. Okay, so we know in our first one that the opposite is going to be equal to 1. And we know the hypotenuse, I'm just going to abbreviate this, is going to be equal to 3. So I could say that a squared plus b squared is equal to c squared. That means that a squared plus 1, we can just plug those values in, is going to be equal to 9. And that means that a is going to be equal, a squared, it's going to be equal to the square root of 8. And we can further simplify that down by going 2 times 4, which is going to be equal to 2 square root of 2. Okay, so that is the value, and this is the adjacent. That's what we just got a calculation for, was our adjacent. Okay, then we have the secant of y is equal to 5/4. Well, that is the same as the cosine of y equal to 4 over 5. So what does that mean? Well, that means the adjacent is going to be equal to 4, and the hypotenuse is going to be equal to 5. So if we have 4 squared plus b squared, that's going to be equal to 5 squared, which means 16 plus b squared is going to be equal to 25, and b squared is equal to 9, which means that b is going to be equal to 3. And this is the opposite in this circumstance. And what's it want us to calculate? It wants us to get the sine of x plus y. So to do that, we are, well, here's another rule that we know. If you want the sine of x plus y, that is going to be equal to, we talked about this rule also earlier, sine of x cosine of y plus sine of y times the cosine of x. All right, so then we just plug in the values that we know. Change back to this color. This is going to be equal to 1/3 times 4 over 5 plus the sine of y times the cosine of x, which is going to be equal to 4 over 15 plus 3 over 5 times 2 over the square root of 2 over 3. I'm just taking the other values that we already calculated, these guys here and this guy right here. And this is going to end up being equal to 4 over 15 plus 6 over square root of 2 over 15, which is equal to 4 plus 6 square root of 2 over 15. Okay, how many more? Oh, these are proof. Okay, we just have 3 more problems, and then I've solved every single problem in that calculus book. This has to be one of the weirdest videos anybody's ever made. I don't even know why I had this idea. It's very strange, and you guys are the ones that are interested in it. Okay, so of course, the tangent of some angle is going to be equal to the sine of that angle over the cosine of that angle. That's just a simplistic rule. And we're going to use that to get rid of this concept of using tangents because we don't like tangents. Okay, so we're going to change this to sine of theta over cosine of theta, which is going to be times the sine of theta plus the cosine. I'm just trying to prove that both of these two things are actually equal. Okay, so I have to convert. Is equal to the secant of theta. Well, this is going to then become sine squared theta over the cosine of theta plus cosine of theta equal to the secant of theta. And then we need to multiply cosine times both of these. Well, rather than rewriting them, I'm just going to take this right here. The denominators obviously have to be exactly the same. And we're going to put this as like this. And cosine of theta is that guy. And this, of course, is going to, we can go and even more simplify this. Whoops, what did I do? Let's get rid of that. Okay, get a smaller eraser. We can go and get rid of one of these. We can make this line a little bit bigger. Just grab that, drag that over there, act as if there was only ever one line. Let's put it like this. Give it enough space like that. And like this, plus, and then we'll go and get our cosine and drag that over here to the middle. And if we do that, well, this gives us another rule. And that is, that rule, remember, the rules are always in orange. If we have the cosine squared theta plus the sine squared theta, this is always going to be equal to 1. And that means that this cancels out. I'll just rewrite it. This is going to cancel out to just being equal to 1 over the cosine of theta, which we know by fact is equal to the secant of that theta. So it's true, because this is what we call a trigonometric identity. Okay, next problem. Okay, now what it wants me to do is prove that this is true. And this is insanely complex, but I'll try to solve it. All right, I have to get a drink of tea before I do this. Approaching 3-hour video. If you're just joining me, what I'm doing, this book is the most common book used in United States universities for teaching calculus. It is thick. Look at it, it's bigger than my head. But anyway, at the very beginning of it, it says you should be able to solve all these problems if you are going to start reading this book and learning about calculus. So what I'm doing is I'm actually solving every single one of those problems all in one video because, I don't know, I just thought it would be interesting. Okay, we hate tangents, so what are we going to do? We are going to get rid of, actually the very first thing I'm going to do is get rid of this prove part and move this over here because this is going to be a little bit more complicated than what we have. I think we only have 2 problems left. This one, yep, I have this one and this one. We have 2 problems left, and then we have beaten every single one of them. Okay, so this is going to become 2 times the sine of x over the cosine of x. And can I also simplify that down? Yes, I am going to also do the same for the tangent on the bottom. So we're going to take this, put this here. This is going to become 1 plus the sine squared, or you know what, I'm going to get rid of this part. I'm sine of x over the cosine of x, put this in parentheses, and then this would be squared, is going to be equal to the sine of 2x. What other rules could we apply? Well, we're going to need this. This is a rule, and that is a over b to the power of c is equal to ac over bc. So I figure this out exactly how to explain this in the smallest amount of space humanly possible. Well, this is basically just going to be squared. So what I'm going to do is I'm going to take that 2, and I'm just going to use that rule to get rid of this. So I'm going to put the squared parts inside of there, plus that. Another rule that I'd like to be able to use is if you have a times b over c, this is going to be, of course, equal to a over b, or a times b times c. So I'm going to also get rid of this part right here, drag this over here, put the 2 in front of there, and drag that there. Just moving some values around. What else can we do? Well, I'm going to try to fix up the complexity that is this mess of fractions. So another rule that I'm going to use is if you have b over c over a, this is going to be equal to c times a over b. And do I have to rewrite this formula to be able to pull that off? Yeah, I can just take that and move it down. Well, I should probably write it out. I've been doing a lot of moving stuff around. So this is going to be 2 sine of x over, I know that's not enough space, cosine of x times 1 plus sine squared x and cosine squared x, which is going to be equal to sine of 2x. It's always still, yeah, I still have space. So we want to get this guy and multiply that through. Well, we can go and get rid of that sine squared, and so this is going to then be equal to cosine x cosine squared x plus sine squared x over cosine x. And again, these rules apply equally. So if you say something like, if you have a over b over c, this is going to be equal to A times C over B. So that's also going to apply. So this then is going to end up being cosine squared x plus sine squared x over cosine x, all are going to be under 2 sine of x, which is going to be equal to 2 sine of x times cosine of x over cosine squared x plus sine squared x. And yes, indeed, here's another rule. I used it earlier. Anytime you have cosine squared of an angle plus the sine squared of an angle, it's going to give you a value of 1. So what does that mean? Well, that means that this is going to cancel out and just give us a value of 1. And in that situation, yes, indeed, we end up having sine 2x is going to be equal to the sine of 2x. How am I doing? Hey, thanks for stopping by. Move. I've been sitting for hours. Move my blood. Oh, get ripped. You know what get ripped means? Do you seriously want me to do that? Get ripped means that I have to lift weights for... I'll do it. I only have one more problem. I'll do it. If you want, I'll be back in a sec. All right, I have sat in this chair for 3 hours doing math problems. Get ripped means that I have to lift a weight as many times as possible. And then I'll do my very last problem. There's only one problem left. All right, let's see how many. I always do my right arm, so this time I'm going to do my left arm. This is, I have no idea how much this weighs. It's 50-some, I think it's 50-some pounds. Okay, it's a kettlebell, so let's see how many I can do. 1, 2. This is a great way to end the whole entire video. I can't do math problems while I lift kettlebell, but I'll try. No, I will not try. Let me see. Because obviously I'm very, very huge. And I'm obviously joking about that. That's as many times as I can do it sitting in a chair. If I got on the floor, I could probably do it about 20 times. All right. I finished college because of you. Thank you very much. Now I have to hydrate. All right. There, I hydrated. Let me drink water also. Thank you. That definitely, that was good. Okay, so for the very final problem, I have to find x if the sine of 2x is equal to sine of x. Okay, so this is asking me to find a range of values that are going to work with this function. And they have to fall, it's just this limited range between 0 and 2 pi. Okay, so what I'm going to need to do here is I need another rule. And this one's called the sum to product identity. And what it says is if I have sine of x minus the sine of y, that is going to be equal to, guess what, I need more space. This is a complicated sort of rule. Okay, so this is equivalent to 2 sine x minus y over 2 times the cosine of x plus y over 2. Okay? So what I can do with that is I can then take this function that we have here, and I know that 2 sine of x minus 2x over 2 times cosine of x plus 2x over 2. Okay? So 2, and then we'll just continue just solving and simplifying. So this ends up being negative x2 times the cosine of 3x2 equal to 0. And then what I need to do is actually solve them separately, because if either one is 0, thank you for following is useful. You alerts follow. What? You alerts follow your face. What? I have no idea what you're saying, Stan. Cover. I have no idea what's going on. Tell me what you're saying, Stan, because I don't understand. You alerts follow your... Oh, yeah. My alerts follow my face. Yes, I set that up on purpose so that every once in a while I turn into a cat or whatever it is. Okay, so if either one of these values is equal to 0, then that means that if one of them is 0, I have to solve them basically separately to find when they are 0. So this is a really complicated problem, which is probably why it's the very last one. So it's cosine of 3x is equal to 2 is equal to 0. Okay, so I have to find that. So I want to use a value for 0 for solving this. So I'm going to have this be 3x over 2 is going to be equal to pi over 2 plus 2 pi n. So I'm using a value for cosine that is going to be equal to 0 in this circumstance. This is a really weird way of solving this, but this is the best that I can come up with. So we'll say 3x is equal to pi. Let's get rid of those 2's plus 2 pi. And then n is going to represent an infinite number of values in the future. You'll see, after I solve all this, I'll explain exactly what n is. N is a little bit more complicated. So I multiplied both values, or most sides, by 2. And then that's going to give me x is going to be equal to pi over 3. There's a good reason why this is the last problem, because it is kind of complex. Is equal to 3 if I divide by 3. And so there's the value for x for the cosine part. And then I'm going to do exactly the same thing for the sine part. So I'm going to have sine of x over 2 is going to be equal to 0. This one's a lot easier. X divided by 2 is equal to 2 pi n. You'll see what the n is in a minute. And then I just multiply both sides by 2. And that tells me that x is going to be equal to 4 pi n. All right, now what I need to do is I need to get the values and combine the solutions. So x is going to end up being equal to pi over 3 plus 4 pi n over 3. And then this is where the n plays in. If I want to find the very first matching value, so I can put in, let's say that I'm going to do this in a different color. If n is equal to 0, then that means that our function is going to return a value of pi over 3. So this is finding this within this range. And then you'll continue changing the value of n until you get to a point where you are equal to 2 pi. So if we have n is equal to 1, well, in that circumstance, this is going to end up being equal to 5 pi over 3. And then you just increase n is equal to 2 and so forth and so on until you reach a point where you get 2 pi. All right. There you go. I solved every single problem. That's the end of it. And like I said, after I get a chance, I will take all of these notes and how I solved every single one of the problems. I'll put it in the description of this video. The video will go on YouTube tomorrow if you want to see it again, or if you whatever. I don't know. I just thought this was a weird challenge that somebody gave me to solve all these ever increasingly complex problems, and I thought that what the heck, I'll do it. And I did it in almost under 3 hours, so not too bad. I'm sweating a little bit, but thank you to everybody that joined me. And like always, I will see you guys next time.